Today we will talk about motion into dimensions. Before starting this new chapter, let's repeat quickly what we did before. Mainly we studied motion in one dimension, in horizontal direction or only in vertical direction, free fall, as you remember. And we considered motion in one dimension with constant acceleration. And in that case, we had three main equations that we can use. The first one was final velocity equal to initial velocity plus or minus acceleration times time. Plus minus, it depends on the direction of the acceleration, or to keep it simple, we can say when velocity increases, we use plus sign. When velocity decreases, we usually use negative sign. This is the first equation. And the second equation, v final square equal to v initial square plus or minus again 2 times acceleration times distance. Actually, it's a displacement. But for simple problems, for simple physics problems, usually the displacement equal to distance. That's why sometimes we say x equal to distance. And the last one, displacement distance equal to initial velocity times time plus or minus 1/2 acceleration time square. These are the main three equations that we can use for motion with constant acceleration. Let's write it here. Constant. A is constant. And what if we have zero acceleration? Zero acceleration means uniform motion with constant velocity. In that case, of course, our equation will be very simple, and we have only one equation: distance equal to velocity times time. This is the equation that you can use when you have a uniform motion, which means velocity constant. So we used these four equations. Actually, it's three. We use it for motion in one dimension. Now, today we will start motion in two dimensions, and again we will be using these three equations. So basically, we don't have any new equation for today. It's we need to just learn how to use these equations for motion in two dimensions. That's all. So let's continue. Let me create new page, and let's consider a stone object, and let's throw it with an angle to the horizontal, to the surface, to the ground. So initial velocity, let it be v0, and the angle with horizontal is alpha, let's say. And of course we have a gravity downward. Yes, gravity is always downward. For our planet, for the Earth, it's approximately equal to 10. And we know that when we throw something, it will come back to the Earth, of course, due to the gravity. So this is the approximate trajectory of the object. If we throw in this way, it will come back. And let's take just any point after t time. Let's say this is a point. Let's consider this point. This is let's call it final point. Yes, f. This is let's call it initial point. So after t time, it will be at point f, which denotes for final, and it will be moving in this direction with velocity vf, approximate direction. And so at final point, if you pay attention, its height was changed. Initial height was equal to 0 at the surface, at the ground. After t time, at point f, height is different than initial. And of course, there was a displacement in horizontal direction. So shortly we can say it moved in this direction, in horizontal direction for x, and also there was a change in height. You can say height h. So that's why we call it motion in 2 dimensions, basically, very simple. There is a motion in horizontal direction, in x direction, and also at the same time there is a motion in vertical direction, in y direction. That's all. And you can apply the previous 3 equations. In order to solve this kind of problems, it's better to draw x and y axes, and we should locate the origin. For these problems, it's simple. We will take as an initial point, as an original point, the point where we throw the object. So this is a x axis, and this is a y axis, and this is the origin. And you know that velocity is a vector, and it has 2 components, x and the y component. At any time, this object has 2 components for velocities, 2 components, x and y. Initially, we have initial velocity in x direction, which is x component of the initial velocity, and let's call it vx, initial. And from the picture, from the figure, it's obvious that VO times cosine alpha will be equal to x component of the velocity, initial x component. And we have a y component, vertical component, let's call it VYI, vertical component of the velocity, and it will be equal to V0 times sine alpha. Same for the velocity at point F. At point F, let me zoom it so you could see it better. So here, this will be Vxf. Let's say this angle will be, of course, less than initial alpha. Let's call it beta. Let's call it for now beta. And there will be vertical velocity. Vertical velocity, let's call it Vyf. Now, we know that we have a gravity only in vertical direction, downward. It means this gravity will affect to the velocity in vertical direction. Gravity will change the velocity in vertical direction. There is no any acceleration, any force in horizontal direction. It means velocity in horizontal direction will never change. Of course, when we ignore all forces in horizontal direction. So velocity will change in vertical direction, velocity in horizontal direction, it will never change. Of course, if we ignore acceleration forces in horizontal direction. So basically it means motion in x direction is uniform motion. So basically Vx equal to constant. In y direction, we have a motion with constant acceleration, and this acceleration equal to gravity. It means for y direction, for vertical direction, you can use previous 3 equations. For x direction, you can use only one equation, x equal to vt. That's all. Okay, let's write these equations. For x direction, x equal to vx times time. Vx means velocity in x direction, which is v0 times cosine alpha times t. So we have only one equation in x direction. And let's come to the y direction, vertical direction. Y direction. As we said before, this is a motion with constant acceleration, so we need to write three equations. Let me write it quickly. The first one, final velocity in vertical direction, vyf, equal to v initial in vertical direction, plus or minus, for this problem, for this figure, it will be minus, because gravity is negative to the y, g times time. So it means v final times sine beta equal to v initial times sine alpha minus gt. This is the first equation. Now let's come to the second equation. V final square equal to v initial square minus 2 times acceleration times height, and the v final equal to v final times sine beta square. Same for the initial velocity in vertical direction, 2gh. This is a second equation. And the last equation, height equal to initial velocity in vertical direction, v0 sine alpha times time minus 1 over 2 gt square. One equation in x direction, and the three equations in vertical direction. First one, this is the second one, and this is the last one. That's all. And by using these three equations, basically you can solve any problems, physics problems related to the motion in 2 dimensions. Further is just a matter of logic, and it depends on the problem. That's all. It's a matter of practice. Let's solve simple problems. Example. Let's say we have a stone and we are throwing it with initial velocity, let's say 10 meters per second, with initial angle with horizontal equal to 30 degrees. So first question, find time flight and the height, maximum height, and also let's find maximum range. Maximum range means maximum displacement in horizontal direction. So we know that this object will come back to the Earth. How we can find time flight? So basically we have a time rise till maximum height, then time fall. When you add these two times, time rise and time fall, it will be time flight. So this is a maximum height. This is a height maximum we need to find, and this is a maximum range, x max. So first of all we need to find time flight. So before solving this example, let me explain. Let me write equation number 3. We know that height equal to initial velocity in vertical direction times time minus 1 over 2 gt square. Standard problem. Basically this is an equation or function of height related to the time. So when you input any value for time in this equation, you will get the height which corresponds to that time. And initially, at the beginning, this height equal to 0, because it's still on the ground. Yes? Time equal to 0, height is still 0. So we can say like this, height at 0 time equal to 0, which is simple. And also, again, it will be 0, it will be 0 after t time. Basically, it will come back. When it will come back to the Earth, at that time, height again will be 0. It means we can go back to the previous equation and make h 0, and we can find time. That's all. Let's continue. So basically, height equal to 0, initial velocity v0 sine alpha t minus 1 over 2 gt square. This is a quadratic equation, and we should get two values for t. And I'm sure first one of them will be 0, because at 0 time height equal to 0. And the second one will be our answer, and it will be time flight, because after that time again height will be equal to 0. So let's continue. Let me take time out of the parenthesis bracket, so it will be v0 sine alpha minus 1 over 2 gt. As you see, this equation has two answers. The first one, from here, it's obvious that time can be equal to 0, and also this part can be equal to 0. So it means we can continue like this. v0 sine alpha minus 1 over 2 gt equal to 0. From here, time equal to 2 times v0 sine alpha over g. After this certain of time, height again will be equal to 0. So this will be our time flight. So let's find 2 times 10 times sine 30, gravity approximately 10. So answer will be 1. Yes, 2 times sine 30 will be equal to 1. So after 1 second, again it will come back to the Earth, to the ground. We answered for the first question. Now it's time to answer for the second question, height maximum. There are a few methods, there are a few ways how to find height maximum. We know that height maximum will be after 0.5 seconds, because time flight equal to 1 second. It means 0.5 seconds it will rise, and also 0.5 seconds it will fall. So total time will be 1 second. So basically height max will be after 0.5 seconds. And it means we can use the same equation, and the time is given. That's all. So let's try this one. Height max equal to, I will use this equation because time equal to 0.5 seconds. v0 sine alpha time over 2, here time is total time, minus 1 over 2 g t over 2 square. So 10 times sine 30 times 0.5 minus 1 over 2, gravity 10, and 0.5 square. From here, answer will be equal to, so height will be 1.25 meters. This is one of the ways. So basically we use it, equation number 3. Now let me use equation number 2. Equation number 2 says that final velocity in vertical direction square equal to initial velocity in vertical direction minus 2 times gravity times height. Of course, let it be maximum height. At maximum height, it will be moving only in horizontal direction. Basically, it will stop its motion in vertical direction. So here, Vy final equal to 0. Because it's maximum height, it will start falling downward. It means it should stop its motion in vertical direction. It will be only moving in horizontal direction. It means V final equal to 0 in vertical direction at maximum height. Initial velocity, we know V0 times sine alpha square minus 2g height max. So from here, maximum height equal to v0 square sine square alpha over 2g, and 10 square sine 30 is 0.5 square over 2, and gravity 10. Again, we will get the same answer, 1.25 meters. So height max again equal to 1.25. So this is a second method. So you can use any of these two methods in order to solve this kind of problems. Now question number 3. We need to find maximum range. Maximum displacement in x direction. So let me use this part. And we know that in x direction, we have a constant velocity, and this velocity is x component, horizontal component of the initial velocity. So x max equal to velocity in x direction times time. Of course, maximum range will be when it will come back to the earth, when it will land, when it will hit the ground again. It means after 1 second. X max equal to v initial times cosine alpha times time, 10 times cosine 30 times 1, and the answer will be 8.66 approximately, 66 meters. This is a maximum range. A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second, as shown in this figure. The height from which the stone is thrown is 45 meters above the ground. First question, how long does it take the stone to reach the ground? So basically we need to find time flight. So first question, find time flight. So let's solve this question, and this is a trajectory of this stone. It will reach the ground. So let's choose our origin. Let's make it y, and this is a x, this is a 0 for x and for y. And we know that height initially will be increasing till its maximum height, then height will decrease. After some time, height again will be 0, and it will continue its motion downward due to the gravity, and after certain time height will be negative height. So when it comes to the ground, when it reaches the ground surface, height will be negative 45. So basically we need to find time after which height will be negative 45. Why negative 45? Because it will land, it will go below the initial origin that we selected. So basically I will be using equation number 3. So height equal to initial velocity in vertical direction, time minus 1 over 2 gt squared. And this height becomes negative 45, and we need to find after time when it will be negative 45 basically. Initial velocity 20, sine 30, unknown time 10, time square. So we need to simply solve this problem. 5t square minus 10t minus 45 equal to 0. So we can divide this equation both sides by 5, so we will have this kind of equation. Time square minus 2t minus 9 equal to 0. As you see, this is a quadratic equation, and this equation has two values, two answers. So let's solve it. 2 plus minus 2 square minus 4 times 1 times minus negative 9 divided by 2. So we can divide by 2 upper part and the below part, so we will have this kind of equation: 1 plus minus, here we will have 1 plus 9, 1 plus minus square root 10. So as you see, we cannot accept negative sign here because we will get negative value, the negative number for the time, and we know that time cannot be negative. So we have only one option: 1 plus square root 10, and this will be approximately 4.16 seconds. After 4.16 seconds, height will be negative 45. Second question: find final velocity that it will hit the ground. So basically at this point velocity will be directed approximately like this, and this is the x component of final velocity, and this is a y component of the final velocity. We know that in horizontal direction velocity never changes for this kind of problems, because there is no any wind, there is no any acceleration, there is no any force in horizontal direction. So we can say that final velocity in x direction equal to v0 times cosine alpha, which is 20 times cosine 30, and the final velocity in x direction, in horizontal direction, will be equal to 17.3. Now we need to find final velocity in vertical direction. Basically, final velocity in vertical direction after 4.16 seconds. We can use equation number 1. Final velocity in y direction equal to initial velocity in y direction minus g times time. Negative gt minus gt because gravity is directed downward. So final velocity equal to initial velocity 20 times sine 30 minus 10 times 4.16. So final velocity in vertical direction will be equal to negative 31.6. This negative sign just gives information about its direction. We choose it our y direction upward, that's why we have a negative sign, because it will be moving downward opposite to the y direction. That's why we get negative sign. Actually its value is 31.6 in vertical direction. Now we need to find final velocity, and this final velocity is a combination of x component and the y component, which is already given. We just calculated it. So final velocity equal to square root final velocity in x direction plus final velocity in y direction, and the 17.3 square plus 31.6 square, and finally we will get this value, approximately 36 meter per second. This is a final velocity.